We previously built a method in the order processor that returned an anonymous type. The problem with this approach is that whoever calls this method has a really hard time to get the values out of the anonymous type. Converting an anonymous type into a tuple should be rather straightforward. The anonymous type is created using the new keyword together with an object initializer, while the tuple is constructed without a keyword and a signature that looks like a method call. It's simply a way to define the grouping of elements. Let's attempt to refactor this method. First, we'll get rid of the new keyword. Then we'll replace the curly braces with parentheses, and we're left with a compiler error because we also need to replace the equals with a colon. That seems to have gotten rid of all the compiler errors, and the code actually compiles. If we now hover the local variable summaries, which is the result of that select, we can see that this is an IEnumerable of a tuple that matches what we've constructed. The compiler inferred all the types for us. The with expression works with a tuple because the tuple is a struct. You can use it together with structs, record types, and anonymous types. Just like with the anonymous type, this gives us a new instance with the modified values. Even though the tuple isn't read-only, it's good practice to work with an instance as if it's immutable. You would especially find this useful if you work in a multi-threaded application. The method signature defines that it returns an object. So from the consumer point of view, using this method hasn't changed. How do we make it easier for anyone that uses the method to consume the result of the tuple? Can you guess? We do the same as when we explicitly declared the types that the tuple was going to be deconstructed into. Replace the return type with a definition of the tuple that we want to return. When this is compiled, the compiler will replace this with the generic value tuple. You could define that you return the exact value tuple as well, but that requires more characters and is a little bit less readable. I prefer that the compiler takes care of this for us. A problem that you will experience now is that when you call this method, while it will return a tuple, the names of the fields on that tuple will not be inferred. This means you'd get item 1, 2, 3, and 4. Just as we did earlier, we can tell the compiler which names we'd like to use. Let's say that the first value in this tuple is a GUID with the name order number. While this won't have an effect when you serialize the tuple, it will show up in IntelliSense if you include this library in different projects. This is because if we look at the generated code, the compiler applies an attribute called tuple element names. This will contain a list of strings for the field names that you have explicitly defined. Where you see the nulls, those are names that you have not explicitly defined. As you can see, you can define one or more of the names. It's a good idea to specify all of them so that you don't confuse yourself or your fellow developers that work with this code. This method is now completed. We've changed the method signature to allow us to return a tuple. The signature makes it look like we have multiple return values. But in reality, we are returning a tuple which is a group of elements. Behind the scenes, it uses a value tuple, which is a struct that will hold the values and references to the objects that we return. Let's head over to the program and see how this works on the consumer side of things. Accessing the fields show that they're displayed using their names as we specified in that method signature. If we make two subsequent calls to process and store the result in two completely different variables, given that both of these tuples have the same values, what do you think is going to happen when we compare these two variables? If you recall, comparing the anonymous types using the equality operator resulted in a reference comparison. However, in this case, the value tuple isn't a reference type. Let's compare these two values and see what happens. As you can see, this comparison returned true. This is because comparing two tuples will perform value-based equality. We could try and change one of the values. And to make it simple, we can use the with expression. Then we can rerun the application. It's now false. This is the expected behavior when using tuples. You can use all the different types of deconstruction that we've looked at earlier. You can take the result from the call to process and assign that to a local variable. This is now used as a tuple, or you can deconstruct it into multiple different variables, or even deconstruct it into existing variables. Optionally, you can use the discard on the values that you do not care about. The same way that you can use a tuple as a return type, you can use it as a parameter on a method. This works with action and func as well. You can use an action, for example, that expects a tuple to be passed into the method. Invoking this delegate lets you pass a tuple as the argument. This works for all methods. You can use the tuple just like you did with a return type. Because the compiler uses the generic tuple behind the scenes, you could even create an extension method that works for all tuples with a specific number of elements and types. We can head over to the extension method library and add an overload to the order extensions. Maybe we want to introduce an overload that accepts a tuple because the tuple represents an order, and we can then produce a report based on that. Remember, extension methods are public static methods. We'll return a string, and the type that we are extending is the tuple. We'll define the group of elements just like we did with a return type. We can give this parameter a name, and now we can access each of the fields of this tuple inside the method. Return a report based on the tuple, and after we're done, we can head back to the program. What's interesting now is that this extension method will immediately work on what's returned from the method process. This is because the tuple that is returned matches the tuple that we defined the extension method for. This extension method will only work for tuples with the exact same definition. It needs to contain 4 elements that have a matching sequence of types. As an example of this, you can construct a tuple with an empty GUID, an integer that is 0, a decimal that is 0, and finally, an empty enumerable of item. That will simply give you an IEnumerable of item. As you see, the extension method generateReport would be available. But if you change the order of the types, it will no longer work. This demonstrates how to use the tuple as parameters to methods. And as a bonus, you added an extension method. If we look at the decompiled code for this extension method, it may become even more clear why and how this works. It's simply an extension method for value tuple of GUID, int, decimal, and IEnumerable of item. There's one more change that I'd like to make before we proceed. The method process accepts an IEnumerable of order, but only returns one summary. I'd like to change this to return an enumerable of tuples. This change is simple. Change the method signature to indicate that you want to return an IEnumerable of the tuple that we defined earlier. Instead of returning just one summary, we can return the entire list of tuples. You're now working with an IEnumerable and not a tuple that can be deconstructed. To iterate through each of the items in the enumerable, we can simply for each, and you'll notice that the assignments and deconstruction of the tuple works for each element in the enumerable. You can then proceed to call generateReport as long as it's not deconstructed into different variables. Working with tuples is powerful, and they provide much more flexibility in comparison to anonymous types. But when it comes to data binding, as we saw with anonymous types, the tuples cannot be used in the same way. So for that use case, you'd still have to rely on the anonymous types, or create an explicit class for that purpose. Now that you've learned about how to define tuples and the ways that they can be deconstructed, it's time to look at how to deconstruct other objects that are not tuples, and why this can be useful.